Mhm.
Hi everyone, today we're gonna present our final project in data analysis on the prediction of diabetes among adults in the US using a nationally representative data from the National Health and Nutrition Examination Survey. So the outline will be background. We'll also discuss some data set description, preparation, feature engineering, model fitting, results, strengths and weaknesses, as well as conclusion. In terms of background, diabetes is a chronic disease that happens when either the pancreas does not produce enough insulin or the body cannot use insulin produced effectively. Diabetes can cause the reduce of life expectancy up to 10 years. These two graphs shows the prevalence and the incidence of people in the United States with type 2 diabetes. We can find that after 1995, both prevalence and incidence of type 2 diabetes in the US increased dramatically. Type 2 diabetes not only introduced the public health problem, it also caused some economic cost. In a report in 2022, it shows like the cost of diabetes was 412.9 billion US dollars, including 106.3 billion in direct cost, which related to disability, presentism, and loss of productivity due to the premature deaths related to diabetes. Diabetes as a chronic disease is manageable and has relatively slower progression compared to other diseases. This is causing additional loss of revenue and extra expenses for health insurance industry. So in the public health world, there is a very famous and commonly used prediction model called ASCVD 10-year risk factor. They used a bunch of social demographics and lab test data to determine individuals' risk of future cardiovascular diseases risk. This gives us a rationale to develop a prediction model for diabetes for both public health and health insurance industry.
So now I will give an overview of the description of our dataset. So our dataset comes from the National Health and Nutrition Survey, which is a program of studies designed to assess the health and nutritional status of adults and children in the US. A nationally representative survey every 2 years with oversampling of historically disadvantaged population groups or specific health topics. So in our study, we will analyze specifically on adults records, which we will have about 5,700 observations. So next, I will discuss the preparation part. So first, we will do the data cleaning. Because based on our raw data, there are a lot of columns that is hard to understand. For example, there is a column called SEQN, which is to track the survey number, and we will convert it into ID for easier understanding. Also, we will have a column DIQ010, which is simply the response, that is the diabetes we want to predict. After that, we will use some criteria, which we will discuss the details in our report, to convert the complex data into the features that were identified by some of the literature review. Like we will have some ordinal features like smoking, income, or education, and we will have some categorical feature and continuous feature as well. After that, we will use pandas in Python to merge everything we have to the dataset that will be used in our final model fitting part. Here, however, in our raw data, we will have a lot of missing values. So here is a summary of the missing rate for each of the features. You can see that for some of the features like alcohol, the missing rate is larger than 50%. So we have to find some imputation method to impute these missing values. So for example, for the continuous values, we will simply use the median to fill all the missing data. And here I show an example of BMI. You can see that the distribution does not change a lot before and after we impute them. And for the categorical and ordinal data, we will use multivariate linear models with random forest imputation, which is a commonly used imputation method described in the paper that we did in our literature review. After that, we will check the reasonability of our imputation. So we will did two tests. First test is the chi-square goodness of fit test, and the second is the Kramer's fit. And we will discuss the details of this part in our report. But here I will show you two examples before and after the data. You can see actually all of the variables can pass the Kramer's V test with the general criteria. So we think that this imputation is reasonable before and after we input the data. And the second test we did is to check whether our imputation captures the correlations and covariances between all of the features. And this is the heat map that shows the correlation between all pairs of the features. Actually, it is very similar, so we can conclude that the imputation is very reasonable. And we will also show details in our report. And after that, we also tried some feature engineering techniques to better optimize our model's performance. Some of the techniques include standardize or normalize some continuous features, or did some polynomial transformation, as well as adds in some interaction terms. We also tried some one-hot encoding for some of the nominal variables. So I will handle it to Yuzo to talk about our model fitting part.
So let's move on to model fitting. This is the overview. Our objective is to predict diabetes using enhanced data with four classification methods: LR, SVM, RF, and KNN. Our evaluation metrics include sensitivity, specificity, accuracy, ROC, and AUC. So for the results, we first did a preliminary analysis. We used the training and testing data sets. Because since LR is a commonly used model in public health, so we did a preliminary LR model to have an overview of the association between features and the outcome. We found that some of the features were not significant associated with diabetes, so we excluded them from our further model fitting. So this is the output of the coefficients. This indicated that age, smoking, and BMI were positively correlated with the diabetes onset, whereas income, education, and diastolic blood pressure were negatively correlated. Smoking and diastolic have a relatively greater impact on the likelihood of diabetes onset. So for the LR results, the model showed high accuracy, effectively predicted diabetes status with social, demographic, lifestyle, and health features. For the KN model, the recall for class 1 was as low as 0.01, so it's safe to say that KN might not be an appropriate algorithm for this problem. We also considered two other models, SVM and the random forest. They both have low precision and recall, so they perform poorly. In this context, our objective was to conduct diabetes screening tool for public health and public insurance industry, not diagnosis. So our primary focus would be to maximize the recall for class 1 to correctly identify true positives while retaining high specificity. As you can see, the AR model has the highest recall for class 1, which is 0.77, much higher than the other three models. So it's decided to stick with AR model.
Then I will talk about the strengths and limitations. We use the most up-to-date circle of enhanced data, and since enhanced data is a nationally representative data, it gives a more generalizable result in the general US population. All of the features we include in our prediction model are non-invasive measurements, which provides a low risk and low cost in the real world settings. For the limitations, because most of the features were based on the self-reported survey, introduced recall bias. Also, since the feature selection we use are from literature review, for future study, we think by using PCA, it may capture novel features. In conclusion, our model and analysis can capture the relationship between the features and the disease outcome. And we had a relatively good performance to predict diabetes onset in the aiming of screening settings. And also, we think our model is beneficial for both public health field and also the health industry. Thank you.